In calculus, we use the product and quotient rules for differentiation in many different contexts. The following are just a couple examples for you to see. Our product rule is the first times the derivative of the second plus the second times the derivative of the first. Okay? In this case, we need to rewrite our problem with fractional exponents before we can go to the derivative. So to rewrite our problem, first we would have x minus 1 to the 1/2. Then we would have 2x plus 3 to the 1/3. So be careful when rewriting. This is important. It's a product rule because we have this multiplied by this. So when we take the derivative, we have the first, so not changed, x minus 1 to the 1/2, times the derivative of the second. So I'm going to change the color. The derivative of the second requires the chain rule. This is another rule that we know. So we have to drop down the 1/3, write 2x plus 3, and we have 1/3 minus 1 will give us negative 2/3. The last part of our chain rule is multiplying by the derivative of the inside. So the derivative of the inside is 2. That is only the first half of our product rule. So we need to go back and say plus the second, which we leave alone, 2x plus 3 to the 1/3. Then we use the chain rule again on the first function. So we have 1/2 times x minus 1. 1/2 minus 1 is negative 1/2. And we have to multiply by the derivative of the inside, which in this case is just 1. That's nice for us. Now we need to simplify. So to simplify our derivative, we have x minus 1 to the 1/2. And then we have a 1/3 and a 2. That'll give me a 2/3. And then I have 2x plus 3 to the negative 2/3. Okay. Then I have plus 2x plus 3, x 1/2. I have 1/2 and 1, that'll leave the 1/2, and x minus 1 to the negative 1/2. Now, as long as you could have gotten to this first step, I would have been okay, but you do need to know how to simplify. The step in simplifying that I want you to get used to is getting these exponents out of fractions and positives. So if it's positive, it's going to stay up. So we have a 2/3. Then we have an x minus 1 to positive 1/2. Positive 1/2 means a square root. Over, we have 2x plus 3, and that is to a negative 2/3. So our root is going to be a cube root, and 2x plus 3 is going to be squared. Take a second to think about that. If you got confused, rewind the video if you need to watch it again. Now the other side, we have a plus, we have a 1/2. Okay, then anything with a positive exponent will stay up top. This is just a 1/2, so I'm just going to have a square root of 2x plus 3 over, this is a negative 1/2, so on the bottom I will have a square root, x minus 1. Let's just clean this up a little bit more, rewrite it one more time. Our final answer will have 2 square root x minus 1 all over 3 cube root 2x plus 3 squared plus square root 2x plus 3 all over 2 times the square root of x minus 1. Now let's do a quotient rule. Remember, a quotient rule, the quotient rule, is low d high minus high d low. Low d high minus high d low all over low squared. Okay, so when we solve this problem, we need to write all of those steps. This is low, this is high. So, to find our derivative, we have low, which is x plus 5. D high, the derivative of 3x is 3. Minus, make sure that you get that sign correct. High is 3x. Times the derivative of low, which is just 1. All over low squared, we'll get x plus 5 squared. And now we simplify. We will distribute this 3, and we will multiply the 3x and the 1. So we have 3x plus 15 minus 3x all over x plus 5 squared. We have a positive 3x and a negative 3x. Those will cancel. So our final answer for the derivative is 15 over x plus 5 squared. We also need to know the derivatives of our trig functions. Okay, I know that you don't like memorizing these, but they must be memorized. Again, we are using our quotient rule, so we have low d high minus high d low all over low squared. So low y prime is low d high, the derivative of cotangent is negative cosecant squared x minus high, which is cotangent, d low, the derivative of sine is cosine, all over low squared. So we have sine x squared. And we'll simplify this once. There's not much to combine. So we will have a negative sine x cosecant squared x minus cotangent x cosine x all over. Remember, the other way to write this power is to write it as sine squared x. And that would be your final answer.